To read and understand electrical drawings, the user must be familiar with many symbols. This course discusses common electrical symbols. These are the objectives for this course. The information that follows provides details on the basic symbols used to represent components in electrical transmission, switching, control, and protection diagrams and schematics. This shows the basic symbols for the various types of transformers. This shows how the basic symbol for the transformer is modified to represent specific types and transformer applications. This shows the most common types of switches and their symbols. The term pole refers to the number of points at which current can enter a switch. Single pole and double switches are shown here, but a switch may have as many poles as it requires to perform a function. The term throw refers to the number of circuits that each pole of a switch can complete or control. This figure provides the common symbols that are used to denote automatic switches and their normal status and/or method of actuation. Here are the pictures and symbols for basic fuses and circuit breakers for single-phase applications. In addition to the graphic symbol, most drawings will also provide the rating of the fuse next to the symbol. The rating is usually in amps, sometimes in milliamps for electronic fuses. When fuses, breakers, or switches are used in three-phase systems, the three-phase symbol combines the single-phase symbol in triplicate, as shown here. This shows the symbol for a removable breaker, which is a standard breaker symbol placed between a set of chevrons. The chevrons represent the point at which the breaker disconnects from the circuit when removed. Here are some other common symbols: relays and contacts, connectors, types of lines, resistors, and other miscellaneous electrical components. The next three slides show how large electrical components can be illustrated in wiring, schematic, or pictorial diagrams. The detail used for these symbols will vary when used in system diagrams. Usually, the amount of detail will reflect the relative importance of a component to the particular diagram. There are three ways to show electrical circuits. They are wiring, schematic, and pictorial diagrams. The two most commonly used are the wiring diagram and the schematic diagram. This table compares these two types of diagrams. The pictorial diagram is usually not found in engineering applications. This shows a simple example of how a schematic diagram compares to a pictorial equivalent. As you can see, the pictorial version is not nearly as useful as the schematic, especially if you are trying to obtain enough information to repair the circuit or describe its operation. These figures provide an example of the relationship between a schematic diagram and a wiring diagram for an air drying unit. Here is a more complex wiring diagram. Notice that the wiring diagram uses both pictorial representations and schematic symbols. And here is a more complex electrical schematic. Notice that the schematic drops all pictorial representations and depicts the electrical system only in symbols. This electrical single-line diagram depicts the major power sources, breakers, loads, and protective devices, thereby providing a useful overall view of the flow of power in a large electrical power distribution system. On these power distribution single lines, even if it is a three-phase system, each load is commonly represented by only a simple circle with a description of the load and its power rating. To read electrical system diagrams and schematics properly, the condition or state of each component must first be understood. For electrical schematics that detail individual relays and contacts, the components are always shown in the de-energized condition, also called the shelf state. To associate the proper relay with the contact or contacts that it operates, each relay is assigned a specific number and/or letter combination. The number or letter code for each relay is carried by all associated contacts. If space permits, the relationship may be emphasized by drawing a dashed line, symbolizing a mechanical connection, between the relay and its contact, or a dashed box around them. This illustrates a switch and a second set of contacts that are operated by the switch. In many cases, the position of one internal switch will affect the position of another. Such switches are called ganged switches and are symbolized by connecting them with a dashed line. In this example, closing switch 1 also closes switch 2. The dashed line is also used to indicate a mechanical interlock between two circuit components. This figure shows two breakers with an interlock between them. In system single-line diagrams, transformers are often represented by the symbol for a single-phase error core transformer. However, that does not necessarily mean that the transformer has an error core or that it is a single phase. Single-line system diagrams are intended to convey only general functional information, similar to the type of information presented on a PNID for a piping system. This shows the most commonly used symbols to indicate how the phases are connected in three-phase windings. This illustrates examples of how these symbols appear in a three-phase single-line diagram.